So I just want to keep emphasizing the idea of index laws as patterns, because if I look at something like this, a to the power negative n, there is a way that we can memorize it, but there's also a way we can try and explore what that really means. Right? If I take one of our index laws already, let's say this one over here, let's say we had 2 squared divided by 2 to the power 4. Right? We know if we use that index law, I'd subtract them, so that'd be 2 minus 4, or just 2 to the power negative 2. But why does it come out like that, right? Well, if I go from this side, if I write that out in the expanded form, I'd get something that looks like this. If I wrote that out, I'd get 2 squared, or 2 times 2. Now, with divided by, I can also write that as a fraction. I can write that all over a fraction there, and I'd have 2 to the power 4, or 2 multiplied by itself 4 times. Then you can see that we have some simplifying going on, right? These would simplify, and these would simplify. They just divide through because they're the exact same, and they're multiplied. What do I get left with? Well, I get left with 2 times 2 in the denominator, or that's just 2 squared. So when we see these patterns here, I can see that there's a negative coefficient here. But if I could rewrite that, I can see it's on the denominator now, but the index is positive. So if I have a to the power negative n, I can write that as I can write that as 1 over a to the power n. Okay? So you can see we've introduced a fraction, and now that index is positive. Another way that some people memorize that is that they say we cross the line and we change the sign. Cross the line and change the sign. So it's basically saying, okay, we cross the line, we put it on the denominator if it's on the numerator. So we've created a fraction, and we've made that index positive now. Right? So if I look at these ones here, right, I want to write these without negative indices. And I know when I've got my index law, I change my index. I write it on the denominator now, and I'm also writing it as a positive index. So this one, I can see would be 1 over a cubed. Right? So I've got a negative 3 there. I put on the denominator, and I write that as a positive index. Now, I just want to be really careful because, like with all of these, the index is only applying to the variable that it's next to, right? So in this case, I've got 3m to the power negative 4. So I know with the negative index, I'm going to introduce a fraction at some point. But what is that fraction actually going to look like? Well, if I actually look at this very carefully, I can see that the negative 4 is only applied to this m variable here. So this 3, that's going to stay where it is. It's actually on the numerator, right? And this m, that's when that goes to the denominator, so I get m to the power 4. So I just want to be really careful with stuff like that. So this one here, part C, what happens when it's on the denominator now, right? Well, if we want to use this cross the line, change the sign, we could use that as well. We could say it's on the denominator now, we'll put it to the numerator, and we make that a positive, right? Or, if we want to see why that actually works, in a sense, what we're actually doing is we're dividing, right? So I'm doing 1 divided by x to the power minus 2. But another way I could write this, because I know x to the power minus 2, using my index law, that's going to be 1 over x squared. And when we're dividing fractions, we don't really have a way to deal with that. So instead, what we do is we take the reciprocal, and then we change that sign to a multiply. So I've got 1 times x squared, and that's just going to leave me with x squared, which you would have gotten if you just written that as the numerator and then changed the sign to a positive, so x squared there. Since we have that kind of shortcut that we can take, when I look at this one, it's much easier to do now. I've got these whole brackets, so it means it's applied to all of it. So I've got p to the power minus 1 over q to the minus 1. And then essentially what I'm going to do, I'm just going to be swapping them. So that q is going to go to the numerator, and p goes to the denominator there.